for you today. So I believe we are ready. So good morning, good afternoon, or good evening, depending on where you're joining us from around the world today. Looks like we have a great group, a lot of familiar names. So welcome everyone. It's always great to see everyone join us for another DevNet session. So today's session is the 7th session in the Programmability with DevNet series this year. Just a few things before we get started. As Christian is presenting today, if you could please use the Q&A panel to ask questions. Please don't wait until the end of the session to start submitting your questions. The sooner y'all start asking questions, the more questions we're going to be able to get to at the end of today's session. Typically, it's around 10 to 15 minutes for questions at the end of the session after the presentation. If at any point today you lose audio or you cannot see the slides or you cannot see his desktop when he shares the demo, please use the chat panel to communicate with me privately, and I will do my best to get you up and running again as quickly as possible. Again, please use the chat panel for any issues. I know the Q&A panel can get a little busy, so that's why I say the chat panel is the easiest way to get to me the quickest if there are any emergencies. It's easier to sort through there. We are recording, so a link to today will be sent out to all registered attendees. You will receive that via email from me personally. It will also be posted on the Programmability with Cisco DevNet blog, and I will go ahead and share that link in the chat window in just a few minutes. And last reminder, after today's session, you actually have to exit out of the WebEx environment, but if you could please take about a minute and a half to take a feedback survey. We are always appreciative of your feedback, and we would love to know what topics y'all are interested in seeing in future sessions. So again, everybody, thank you so much for joining us today and giving us an hour out of your busy schedule to join us for today's session. As I mentioned a second ago, this is the 7th session of the Programmability with DevNet series. Before, during, and after a security attack. And I did just want to do a quick reminder that the next session is coming up quickly. It is next week, May 8th, and that session is Play with Linux and Python on Networking Devices. So again, as soon as we get started with today's actual content, I will share the link to the DevNet series where you can go and you can access all of the recordings and all the slide decks for all of the sessions that you see here on the screen, as well as register for next week's session regarding Linux and Python. So I'm going to go through this very quickly because, again, I see a lot of familiar names on today's call, so I'm pretty sure most of you have sat through this already. But we are doing a raffle at the end of this series. Again, it'll be at the end of the series at the end of June. We'll be raffling off a total of 15 Amazon gift cards in the amount of $25 US. So 10 of these Amazon gift cards will be raffled off to everyone who participated in all of the live sessions. So if you're in today's session and if you've joined the other sessions, you're on a good start, and hopefully you'll get a gift card. The last 5 of those 15 gift cards will come from everyone who has viewed or downloaded all of the recordings. So we understand that not everyone can join all the live sessions between school and other commitments in your life, but you can still earn a gift card if you just view or download the recordings. Certificate of participation, this always comes up in the chat window in the Q&A panel. There will be a certificate of participation that you can sign up for at the end of the series. So in June, in that 9th session, I will share a link where you can go and sign up for that certificate of participation. And within about a month, you'll see that certificate of participation end up in your inbox. So again, please join us for the June session so you can get that link where you can sign up for a certificate of participation for the Programmability series. So with that, I am going to do a quick introduction for our speaker today, and then I'm going to pass the floor over to him. So joining us today, we have Christian Veer. He is a technical leader and developer advocate in the security realm here at Cisco DevNet. So welcome, Christian, and the floor is all yours. If you'd like to add anything else about yourself that you'd like the students to know, go ahead and feel free to do so. But thank you for joining us to deliver a wonderful presentation today. Welcome. And
I am from Seattle, and it's a lovely day today here. It's sunny and nice, and we're gonna have wonderful 45 minutes, I think, going forward. So you can use it as a reference point in terms of your career building which you are planning. So security is on top of everyone's mind. It's a great career track, and hopefully I will inspire you guys to look forward or think about creating your career in this field. So what I'm today going to cover is going to give you a little bit of idea about security. You can treat it as security 101, and then we will think about some workflows, how we protect or how we play defense using APIs. So more you automate, more faster you can detect threats. And that's what I'm going to cover in today's presentation. So let's dive in. I've already been introduced. You can follow me on Twitter, CISCO. What I'm going to cover today is basically give you a little bit of overview about how to go about in security. And then we're going to cover a little bit on Firepower REST API. Firepower is one of our firewalls, which is next generation firewall. ThreatGrid API. ThreatGrid is our CISCO systems sandboxing technology, and I will cover what sandboxing mean in terms of security. Then we have Umbrella Investigate API and Umbrella Enforcement API. Umbrella is our product which does DNS filtering, and I'll cover why DNS matters. And for Endpoint is our endpoint security solution, and it has very excellent APIs, and we're going to look at it why it comes handy. ICE is our identity service engine, and it has a REST API, and it is a very important component in defense, and we will see that as well during our workflow, what we will do with ICE. And then hopefully, if time permits, we will have some demo as well. So let's get started. So I'm gonna start with like a zero-day security context, like what does zero-day threat means, how do you go securing about it. There is some understanding I will try to build around Cisco security product with respect to RESTful APIs, and how can you leverage APIs to create stronger security workflows, because more you automate, the better security you can achieve, and most likely you can achieve that because you can reduce the detection time. And you can gather intelligence from multiple places, but the point is that can you make that intelligence actionable, right? So you know that there is threat which exists, can you take remediation actions about it? And how can you automate that intelligence gathering and remediation both? There will be simple introduction to how to deal with zero-day threats, like simple workflow. So as we all can agree, I think that everyone is embracing digital transformation, and it's awesome because you will be watching a show on Netflix, and then maybe a couple of hours later you will be doing a course in AI from MIT. I mean, that's what has been enabled, right, by a digital transformation. But like economists generally will say, there are no free lunches, and hence it comes with its problem. So one of the big problems which we see is that and this is very sad statistics if you look at it. These statistics are coming from Cisco cybersecurity reports, which we publish every 6 months. And so 90% of organizations are not fully aware of devices accessing their network. Right? By 2020, 2/3 of all traffic will be IP traffic, and there will be 21 billion IoT devices. And 80% of that traffic, which is IP traffic, will be encrypted. So just imagine the complexity now. 90% don't even know how, like, fully aware the devices accessing their network, and the traffic of those devices is 80% is encrypted. Means there is zero visibility. You're already very poor on visibility. Now you are losing more visibility because end-to-end the applications are encrypting traffic. And the adversaries will take full advantage of this, right? So from the adversaries' perspective, they are constantly evolving, they're constantly getting smarter and better, right? So they are highly motivated. They do target attacks, means they have attacks crafted exclusively for an organization or a country. Some of these adversaries are very well funded. They are funded by government organizations, so they have unlimited funds. Some of them are funded by mafia or some other organizations which tend to have a lot of funds. So there is a lot of sophistication. So whatever defense you will put in your network, these guys have access to that defense as well, because they can buy the same defense, they can find holes in that defense. So they are highly targeted, highly motivated. They do social engineering very strong. They target people exclusively to figure out where is the weak points are. So they have a lot of that type of sophistication in them. The other important thing which is happening is the insider threat. Sometimes the insider threat can be some employee in an organization just trying to be very productive. He has no way to share a file to a customer or share a file to a partner, or it's a colleague, he just puts it on cloud somewhere. The data has been leaked, right? So it might have some important information. So there can be that type of threats. The other threats may be that someone walking behind you and you didn't care through the door and they plugged in something in the network, right? And so there are a lot of that type of threats which are evolving and which is very common now. The part which we care about most when we play defense is this part. It takes around 191 days to detect if there is an attack. So let's be frank, attacks will happen. We care about from the defense side is that can we reduce this time of detection, right? And on top of that, it takes 66 days to contain. So if you guys remember, it took some time for, if you look at Starwood and Marriott's case, when Starwood assets was acquired by Marriott, the adversaries were in that network for a while. When Marriott engineers did their diligences, they figured it out that there is an attack, there is a data leakage breach which happened, and so it took a lot of time for them to contain it. So that is what is the main target here, is how can we do that. So the question comes to everyone's mind is, how do we start our defense? Well, if I am a CISCO guy, I will try to say this, but I'm just kidding. Let's move on. I think the first step you do is know your network. You need to understand how your network posture looks like. Who are your users? What type of applications do they use? What servers are there? What operating system is on your network? What kind of files generally get exchanged in your network? So knowing your network is the first step. Understanding the user behavior, understanding what they do on your network is very important. The second part is to understand its weakness. And to understand its weakness, you have to hire an awesome security team. You have to invest in people. You have to dig holes, find vulnerabilities. What are the vulnerabilities exist on the user side? How often do they change passwords? Right? What type of passwords are they doing? Can you enforce certain strong passwords? Right? What type of client applications do they use? What are the vulnerabilities in those applications? When they exchange PDFs and JPEGs, they are exchanging all kind of files. What vulnerabilities exist on those files? Right? If you're using a lot of network equipment, your IoT devices, what vulnerabilities do exist on them? Do they ever get software update or not? All that you can have good tools to figure this out, but you need to hire an awesome team which will use those tools. So the first thing I would say is invest in people and figure out vulnerabilities in your network. That's the first step before someone else figure out. And then the second part which comes is, once you know your vulnerabilities, now you know what possible attacks can happen to you. So you can go buy threat intel, you can install state-of-the-art firewalls, you can do all kind of tooling, you can get all kind of eventing, you can create some awesome workflows to contain the threats if they come in, because you know your network really well, you already figured out its vulnerabilities. Now you have excellent tool set with you, which will keep on improving your workflows. But the best tool in security is segmentation, in my opinion, right? Segment your network, segment. So that's the only way we can protect really, really well. So segmentation helps significantly in terms of like how your valuable assets, how you will define policies, how people will access those assets, who can get in. Even though if there is a breach, and if you are very well segmented, you can contain the data breach significantly well. So if you want to walk away from this presentation, like how I should, if someone asks you how to defend a network, how to defend from the possible attack, I think what the straight away answer should be segment. You have to segment the network. So do not forget this. This is the best answer you can give because this is the best tool you have in security, right? So let's baseline a little bit of terminology, right? What is a zero-day attack? I think the equation sums it really, really well, right? Zero-day attack is some unfixed vulnerability and someone with externally have a knowledge and a working exploit. That's a zero-day attack. Means, let's say, for example, if I take Microsoft, if they have some unfixed vulnerability in their OS, and there is an exploit which is out there with someone, and someone outside Microsoft knows about it, right? So that means that entity which is outside Microsoft has given 0 day or 0 minute or 0 hour to Microsoft engineers to fix that vulnerability. It means they can immediately attack. There is no time to fix that vulnerability. And that's why we call it zero-day attack. Developers have zero time to fix the vulnerability, right? So there can be, most of the time, we developers, when we write code, we introduce zero-day vulnerabilities like buffer overflow or cross-site scripting or whatnot, right? So there are 1,000 types of vulnerabilities you can introduce when you write code, and the adversaries take advantage of that. Most of the time, we are not aware of them. We figure out later part of the, either some security research group will figure it out. If that is the case, then they might give some time to, for example, to Microsoft, to CISCO, or whoever has vulnerability. They will give them, most likely the what you call the responsible black hats will give that entity some time to fix that vulnerability before they make that knowledge external, right? But most of the time, if you are on offense, and you're offensive black hat, you will probably go ahead and try to exploit that vulnerability, right? So that's what zero-day attacks are. There are zero-day worms, means you have absolutely no clue that worms is in the space. You don't know about it. There's the zero-day malware, zero-day virus. This is a brand new strain which just came. You have absolutely no clue how to deal with it, or it has not produced any artifact. You're not aware of anything about it. And so there are zero-day, these are the entities. So how does the attack happen, right? Let's look at simple attacks. So that's very famous, I think you guys may have heard. A ransomware, WannaCry is a good strain to look at. It has created a lot of havoc. A lot of people were concerned about it. A lot of people got actually attacked by it as well. So basically, there are two ways the infection vector works, and we are using the same terminology which you use in human virus interaction. So the infection vector in ransomware generally uses web or email. So someone has done a lot of work in social engineering to make you believe that whatever information is coming through web or email is legit, and the beauty of social engineering is that they will make you click. Right, so if they make you click, they won, right? So that's the first part. They have done a lot of investment in this. They have hired really smart people to do that social crafting, and so they get you click. Once you click, then ransomware takes control of your targeted system. So in your case, if you are using at home, it will be your PC, and what it will do, it will encrypt all these files which you have on that PC or the whole disk, and the system is hostage, then it will actually ask for ransomware. Generally, the Bitcoins is their favorite currency. So the way the infection spread is that you click a malvertising which is happening on some website, or you click a link on an email, the malicious infrastructure is downloaded. Sometimes it may come in a form of PDF or JPEG, and it's an empty file. It might have further instructions to download the further key, because sometimes what ransomwares are written the way that they want to evade sandboxes. So they may pretend to be something else, but eventually they will download a malicious infrastructure. They will encrypt. They will contact the command and control center. They will encrypt the keys, send it to command and control center, and then the file are inaccessible. Same. It doesn't matter whether it's a web-based infection or email-based infection. It requires all these 4 to 5 steps. But the important thing here is, if you look at, these are the variants of WannaCry. If you look at it, most of them, they are finding their command and control center using DNS. Means IPs are expensive and traceable. So it is a very big investment on their part, because they are doing huge investment too when they are crafting these attacks. So they want to hide themselves, and the best way to hide yourself is in domains. You can create multiple subdomains, and so what happens, domains has like 50 subdomains. Subdomains can have multiple 50 subdomains. So it's very easy to hide under that domain infrastructure, and it's easy to look up. It's easy to stand up. So that's why DNS filtering becomes extremely easy, because if you can cut the cord, they cannot look up their command and control center. It's just a piece of software on your machine, because it cannot do anything if it cannot find home. So if we can block it on DNS level, it can't do lookup, then we have already cut the cord in terms of software doing anything malicious on your machine. So the first part when the attack happens is detection or hunt, right? So whether you're doing active threat hunting or you're doing detection, in theory you're going to do the same thing. Its only thing is that there are few organizations which are there in this world, maybe 10% of Fortune 500 companies, which have very sophisticated threat hunting teams. They proactively go and hunt. They figure out what type of attacks can possibly happen. So they are proactively hunting. By the way, this is a great career. So if you go on Google and look for, type in keywords, threat hunting jobs, you will find lots of opening out there. So because more and more organizations want to do active threat hunting, and it's amazing career opportunity, and very interesting thing to do. You get to play Sherlock Holmes pretty much every day. So threat hunting is done proactively, detection is reactive. So something happened and you want to now figure out what happened, right? But the workflow will be quite similar workflow. So if you look at the pyramid of pain, whether you hunt or detect, and I want you guys to walk through this a little bit. So first thing we look at is files. So something comes in terms of file. Malware comes as a file, right? Whether it comes hidden in a PDF or JPEG, or it comes as a exe, or some way the file is coming. And each file has hash values, right? You can get the hash of that file. So if you look at the hash of the file, you can compare it. You can go to. So by the way, sandboxing, I'm using that word. I've not explained to you guys. Sandboxing in security, if you're not aware of it, is basically like the word sandbox. So it's like it's a software on which you can actually explode a malware and see its behavior, right? So what it does, it can spin a VM, a virtual machine, and in that, like for example, if the malware is crafted for Windows, you will spin a Windows VM, and you will put the malware in that VM and see what it does. So when it explodes the malware, it does certain things. It modifies certain registry files, window registry files. It installs maybe 3 or 4 more software on machine. It changes some files. It deletes some files. It does a bunch of stuff on the host. Those things are called host artifacts. So you can understand that behavior what changes it is making in host. If you compare it to human virus infection, the artifacts would be like high fever, sneezing, runny eyes, or whatever. Similarly, there's a bunch of stuff which happens when the software comes and do malicious activity on OS. It tries to modify certain things on the OS. Those are called host artifacts. Then there are network artifacts as well. So it means network artifacts would be that which IP did it try to contact, which domain did it try to contact, which domain it looked up. It might go to multiple domains, right? Then another network artifact would be like it is sending 22 bytes on this address. It is sending 37 bytes on this address. So those are what you call the network artifacts, right? So that's why I wanted to clarify it. You can only see all of this if you see the behavior of malware. So you have to put it in a sandbox and let it run its cycle through so you can actually study it. And that's why there are sandboxes. There are multiple types of sandboxes. They can be like dynamic or static. Some can do dynamic analysis, some only do static analysis, some can do everything. So one of our products, CISCO product, is CISCO Threat Grid, and Threat Grid can do both static and dynamic analysis. And so you can upload sample there. If it already has seen those samples, it will already give you information about it. So if you give it a hash value, it will tell you whether it has seen that sample before. If it has, then you can directly query like, hey, give me all the network artifacts, give me all the domain and IPs associated with it. So you can go further analyze whether these domains and IPs are malicious or not. Right? And then it can tell you as well, yes, because most of the sandboxes can establish whether those files or samples you have uploaded or those hash values are malicious or not, because they have come up with an algorithm by which they can figure out what malicious behavior is not. So anything in Threat Grid, any score above 90 generally is malicious, it's bad, it's malware, it's established. VirusTotal does the convictions, which is a free service available via Google. I think Google owns VirusTotal now, so it may show you that I have convicted this file so many times, and that established convictions that's established whether it is a malware or not. So just wanted to give you guys that background. Now we can look at this pyramid of pain. So hash values generally are trivial because most of the sandboxes have either seen those samples, or you can upload a sample and explode it and figure out whether it is bad or good. IP addresses is also very easy. I mean, if it is bad, somehow there are ways to establish whether it is bad or not. Same thing with domain. It's simple. It's a little tricky, but it's still simple, because domains can have subdomains, subdomains can have multiple levels of domains, right? So it's still simple, but we can figure out, like CISCO product, CISCO umbrella can give you dispositions on domains. I think VirusTotal can give you dispositions on domains as well. Network and host artifacts, these are annoying, right? So you have to do a lot of behavioral analysis. It gets annoying. What challenging part comes up is in the top of the pyramid is the tools they bring in. So let's say, like I said, that it might come as in a PDF file to fool your sandbox, but then it morphs into a JPEG file and downloads a toolkit separately, or it does some other tricks with how it steals the hash of your passwords, pass it along to something else. So all those tools they bring to work in your infrastructures becomes challenging, uncovering them. And then techniques, tools, and procedures, tactics and procedures which they bring, right? The social crafting they do, or different techniques they use to do recon in your network. All that is very tough to figure out. And when you do active threat hunting, you focus a lot on those aspects to figure out. But it doesn't matter whether you are doing reactive detection or you're doing active hunt. This is your pyramid of pain. This is the challenge you have. So how do you go about doing it, right? So the first step is to create a hypothesis, right? So whether you're hunting or you're detecting, you have to create some hypothesis. You have to start from somewhere. And so, for example, let's say if you're part of a security operations team, one of your employee was visiting Ukraine. Ukraine is very high probability, if someone used public IP, high probability of getting infections. And when that PC comes back in your network, you want to investigate whether my hypothesis that Ukraine is very high infection area is true or not. You try to investigate. So first thing you do when that PC comes back in your network, like I talked in the very beginning, segment, it should not come into the main network. It should live in a quarantine zone because you have segmented your network. Because you are going to investigate first, right? So you will try to uncover any TTPs which exist there, and figure out if there is something wrong with this PC. If you figured something out, you inform and enrich your models. You have created some workflow, some models, and if you prove it, yeah, wrong or right, based on that, your models get benefited when something happens next time. And you can automate this workflow as well, right? And I would recommend that we should always automate that workflow. So this is, it doesn't matter whether you're detecting it or hunting, it's the same kind of like a loop which you have to fulfill. And now let's quickly jump into the remediation part. So what I mean to say is defense. So if you're active threat hunting, then you will bolster your defense. If you're reactive or you are doing detection, then you will do remediation because the infection already exists in your network. There are already targets which you probably will identify which has this infection. So how do you go remediating it? How do you stop that further infecting your network? Or if you're actively hunting, then you uncovered these TTPs, then how can you raise your defense? So it's again the same thing, right? So the goal you have, so this is the current model, like very first slide, if you guys remember in the beginning, what we had is that 161 days to detect and around on average 91 days to respond, right? So what our goal is as a security team, defense team, is to reduce this gap, right? So threat comes, we immediately detect it and we respond, right? How do we contain it? So one of the ways to do that is if you can automate your workflow. Whatever workflow you have, your remediation workflow, threat hunting workflow, threat detection workflow, can you automate them? And the best way to automate them is because and the reason we can automate them today is that most of the products, whether it is competitive products of Cisco or Cisco, most of the products out there have APIs, and most of the security tools are programmable, and REST is kind of like a de facto standard used by most of the products out there. And this is how REST API works. I think you guys are going through this programmability series, so you guys have already got some context of it. But I just wanted to remind you guys that you can write your own client, HTTP client, and generally it's a secured connection, so it's a HTTPS client, and all you do is 4 methods. So basically, get is read, post is update, post is create new object, put is update, and delete. You just, if you don't want something, you get rid of it. Generally, the request is sent with JSON as the payload, or the response is given to you back in the JSON as a payload. JSON is a very human readable form of data which you can actually get back from the server and do something meaningful out of it. So basically, think of it as a client and a server model, in which client asks for certain things from the server and server responds back based on the request done by the client. To do that, generally you have to authenticate yourself and use the appropriate method, and that is already been defined by these API documentations. So this is what we're going to look at. The first product which I'm introducing you guys here is Cisco Firepower Next Generation Firewall. So it's not just traditional firewall, it has IPS and IDS, which is intrusion prevention system and intrusion detection system included in it. So you can monitor threats really. So it's a fully integrated threat focused platform, and it has done integration not only with a security product, but other stuff like ICE and WSA, ESA, and you can do a lot of analytics on top of the data, like events which are happening on that. So that's the beauty of it. There are three ways you can manage this NGFW, which is next generation firewall. One is if you have more than like 50 or 100 or 200 of these firewalls installed, then you will be using what you call Firepower Management Center. It's kind of like an off-box management center. So you tell all your firewalls to find this FMC, and they will find this management center, right? So you just say, hey, the manager is remote, and you give the address of that manager. But there is on-box manager as well. So let's say if you are a small organization running 5-6 devices, there is a management on the box. That something looks like from the UI perspective, like your home router, and everything is simplified in that UI, and it has a full-blown API. So if you want to write your own Firepower Management Center, you can write your own Firepower Management Center because the APIs are available on the box. And then there is a cloud-based service available as well. If you guys are familiar with Meraki, this is something in those Meraki lines, like simplify managing multiple firewalls using cloud services. This is our sandboxing solution. I kind of touched on it a little bit, so I won't spend a lot of time. This is ThreatCrit. It can do automated analysis, both static and dynamic, and do global correlation. And what you get back from it is threat score, like I talked about. You get observables like domains, IP, host artifact, network artifact, the full analysis report. All the behavior indicators you will get from ThreatCrit, and we will look at some of that data hopefully with our API calls. It has a full-featured API. In fact, you get more features if you use API in this product than the UI itself. You can upload samples, you can download malware sample, and you can get full intelligence feeds from it as well. The next product which we're going to use in our workflow is Umbrella. Umbrella is your first line of defense. Does DNS filtering for us. As you could see, if you cannot find command and control centers, if the software or the malware which has actually infiltrated your network cannot find command and control center, it's a useless piece of software on the machine. It just can't do any more damage. And that's why this is really, really important. And most of the lookups are done using DNS. So if we can do blocking on DNS, that's pretty awesome because they cannot find home. There are multiple APIs on Umbrella. Enforcement API actually helps you. So let's say if you found from different intelligence, threat intelligence or threat event systems, if you found there are certain URLs, certain domains which are risky, you can actually use enforcement API to enforce those URLs. You can just say, hey, I want these all risky URLs blocked to, or these domains to be blocked to. So you can do that enforcement using this API. If Umbrella already has knowledge about a domain that it's already malicious, it will do it automatically anyway. But there are certain risky domains are out there which Umbrella has now established that they are malicious, but you have established because of your threat intelligence or the observables you are getting from your threat intelligence systems, then you can actually completely block them. This is needed for CISCO threat response. We have a new tool, threat response. Hopefully I'll have time to show you guys. It's a pretty good tool, and it's built on top of APIs. Same APIs which I'm talking to you guys right now. Umbrella Investigate is an API where you can actually go and check the status or disposition of certain domains, IP address or subset of domains. It's basically, it's an intelligence system. It's a database. It's not free. It's very expensive. It's sold completely separate. There's an extra license. Basically, if let's say if you're using Splunk, you have lots of log you're collecting from a lot of places, and there are a lot of IPs and domains in it. You want to make sure that these IPs and domains are not malicious, so you can actually write a plugin from Splunk using APIs that each time I get these IPs and domains in my logs, make sure You go to Umbrella and get dispositions on them. If they're malicious, I want it to be marked. I want to be alarm to be raised. You can do that type of integration. It's pretty cool on that perspective. And for endpoint is our endpoint solution. It's the way it is different from other endpoint solution is that you can, if you're running Cisco firewalls, you have Cisco Umbrella, AMP, what it does is if you detect on endpoint, you cannot just block on endpoint, you go block on firewall as well, you can go block on Umbrella as well. So you have more coverage, and you can do actually more broad enforcement as well. And since it uses underneath the threat grid, so it can do dynamic analysis of files as the files are downloaded on an endpoint. So you can do a lot of that type of dispositions really quickly. It has full-blown API which you can use. Full-blown API, so you can use it for triage, for protection. You can do active threat hunting using those, subscribing to the event stream. You can do full blacklist, whitelist of endpoints, right? So if something came from Ukraine, you can have a policy there that immediately it should be in blacklist, sit in quarantine, let's figure out if it is clean. I'm not just circling Ukraine, so don't get me wrong, I'm just taking it as an example. So Cisco ICE is our identity engine. And what it does, it's basically a radius server on steroids. So basically, one of the points when we started this conversation was that 90% of organizations are not aware of what devices are on their network. ICE can give you that context. It's very rich context it can provide, like who used that, who is using what, who got on network, what type of asset did they bring to network, what they're doing on the network. There's a lot of that information which can be accessed through ICE. And then shared using APIs to partner ecosystem, depending on who is subscribing for those events. Who is doing what, like you say, who, when, what, where, how, health threats, every information is there with the ICE. All of these technologies which you saw is backed by Tallis. Tallis is our security research group. Like I told you guys, these are the guys who are looking at zero-day threats. They are figuring out what vulnerabilities do exist in software. They're actively working on it. They're doing reverse engineering of malware. They're looking at all these assets, right? And they are creating this intel which they're feeding all our network, all our entities which I just showed. And they share it, they write blog. Actually, if you are interested in the career in this field, I will highly recommend go to Tallis, does in Google say Tallis blogs. You will get to their page, and every week they publish a couple of blogs. Every month they publish what we call the Beers with Tallis. It's a podcast, and you can listen to that podcast. A lot of valuable information is there. So that's very important. I wanted you guys to know. So here is our mission. So we have this bad guy, and we have to figure out who is this bad guy. Right now, we don't know anything about it. Right. So what would be the simple workflow? Right. So we have to deal with this threat. We don't know anything about it. So how do we deal with this threat? So everything, if you look at it, everything starts from the endpoint. Right. So let's identify if there are any rogue endpoints. So I walk into office in the morning, I look at my endpoint logs, right, and figure out if there is a malware or something which looks like malware or something close to malware has executed, because AMP will flag it. If it has executed, then first thing I want to do is use ICE and quarantine these endpoints. Means I have done a beautiful segmentation of my network. If I suspect that this is a malware and I have no clue about this malware, let me use ICE and first quarantine so that it doesn't further infect my network. So that I'm going to put it, and they will know, and it cannot do any data breach. So I'm going to put that endpoint into into a quarantine zone. The third thing I'm going to do is use the AMP data AMP will provide me a little bit more data than just the MAC addresses of the host where the malware is executed. It will even also say, hey, this is the reason I see why it is a malware execution, because these are the SHA which is associated. This is the file I think I found suspicious, and this is the SHA associated with it, and it will give you that SHA as well. So what you do is you take that SHA and you go to ThreatGrid, which is your sandbox solution, and you say, hey, ThreatGrid asks the API using APIs, have you seen this? What is your disposition on that? Have you seen it? What are the observables associated with it? If it has seen that, it will always provide you some observables. These are the IPs, these are the domains, these are the behavior indicators, and yes, we have established using our correlation models that this is actually a malware. And if it has not seen it, what you will do is you will upload the sample and explode it and see what it can come up with. And once you get the observables back from ThreatGrid, you will like to know the disposition from Umbrella that, hey, we found these domains from ThreatGrid, because ThreatGrid will provide you all the domains. To evade sandboxes, sometimes malwares may look up even completely clean and safe domains. They may look up CISCO.com, they may look up Google.com, they may look up Facebook.com, they may test the internet connection, they may go to AT&T.com. So and they want to evade the sandbox too, just fool the sandbox too, so they just do all these arbitrary connections. So from the sandbox perspective, it will give you the report back that, hey, it contacted Google, it contacted Cisco, it contacted Microsoft.com. That doesn't mean that those domains are malicious. But from the sandbox perspective, it will report you everything. So now it's your responsibility to go to Umbrella and contextualize it, get disposition, what domains are meaningful to both block, right? Which are risky, which are malicious, and which one would you block? So that's what you're going to do. The next step would be you will go to the Umbrella enforcement and you will say, you know what, I found this from these domains, seems to be risky, and I want no more connection going out to these domains, block them all, so they cannot call home. Right? And finally, what you will do is that you will use APIs on top of your firewalls, and you will say, hey, block these domains on firewall as well, because, okay, there might be some, you blocked it on Umbrella, but there might be some corner edge cases where you want protection on firewalls as well. So you block it on firewalls. So this is kind of like a simple workflow. You can do full integration. You'd use AMP, then you use ICE to do the containment. ThreatGrid gathered the intelligence, and this is all happening, like you could say, we are passing MAC to ICE to block, then we are passing SHA-256 to ThreatGrid. This is our file hash we are passing to ThreatGrid, and ThreatGrid will give us some domains which we will pass to Umbrella. Umbrella will give us disposition on domains which we can block, and same domains can be blocked on the device as well. So how do you go about doing this? The first thing you do if you're automating is either choose your programming language. Python is awesome because Python is a lot of crowdsourcing is inbuilt in Python. It means if you imagine that you want to build something and write a code, somebody may have in those lines may have done something for you. So there's a lot of code which is available which you can reuse, and so hence it's the language to go. Very popular, especially with DevOps culture or SecDevOps culture. It's a popular language. You might require a text editor. Atom is one of the good text editor, or you may use Visual Studio Code. That's what I like. It's a full IDE, or PyCharm. That's another IDE, integrated development environment. And then you just code. You know the documentation. You can go find documentation, or you can go to DevNet Learning Labs. You can find a lot of help over there, and you get coding. So some of the links which I have here, we have a full video series on Firepower. You can go over to this URL and learn how to code against Firepower. We have Sandbox available to you. This Sandbox is different than the security sandbox. This is where you have NGFW running. And so the NGFW is Next Generation Firewall, and Firepower Management Center you can book on DevNet and then play with those APIs. We have a whole video series on Umbrella as well on developer.cisco.com, how to code against Umbrella, so you can learn there. There is a whole track which we have put together, security track, where you can learn to code against all our APIs. That's the URL for it. I'm going to use some code here, and unfortunately my dcloud is not behaving today, so I'm not sure if I will be able to connect to the firewall and ICE. But let's look at some of those, some of the code which is actually up and running. So if you go to this URL, you can see there's code over here. You can play with it at your leisure. It's there in the deck. So first thing I will do is I just downloaded this code over here. So first thing I did is that you have this API.cfg over here. So if I open this file, this is a good habit to put a template file so that by accident you don't check in your login password information in GitHub, because it's public and it's dangerous. So I have put a template here. So in this template, what I did is that I put all the keys which I need to put in if I need to talk to these APIs. So APIs, you can either talk using username, password, or you will use tokens, or you will use OAuth tokens. There is some way you have to identify yourself. So good habit to learn is never check in that token into GitHub. That's why I created this template file. And if you look at git ignore, is a file in which you can put like which files you don't want to be uploaded. So over here you could see I said block these files, don't upload them ever, right? So git will look at this git ignore file, and it will completely never upload these files which I have put here. So in my API.cfg, I have all my keys, and so to work with Umbrella, with ThreadCrate, and it will never get uploaded, right? So if I look at the code, let's say for example, first code we have is amp findmalware.py. py is the extension for Python. So my Visual Studio code over here is coming up. You guys will look at it. So over here, what I'm doing is I've imported some of these packages. These are some packages which are already been written by someone else, and I can totally reuse it. And that's the beauty of Python. So let's say if I have to do HTTP request, I don't have to write a HTTP request client and server. The request provides me that client, and I'm going to use it. So first part I'm doing is I'm reading the CFG file, right? The API.cfg, which contains all my AMP API key. I'm reading that over here, storing in these. Then I've written a method called getAmp. So what it does the get request. So this one line over here will do my whole HTTP request. Right? That's the beauty of Python, right? I'm creating this URL over here. That URL is getting passed to this function, right? So I'm calling that function from here, right? This is my main over here. I'm calling this function over here, that getAmp. Once I get that response back, I'm parsing that response. You see JSON dump over here. I'm passing that response, and this is how it's basically when you get the JSON back, it's kind of like a dictionary, a Python data structure dictionary, and you can parse it like you would parse dictionary, right? So so that's what I'm doing here. I'm parsing two things I care about. One is the MAC address, so I can pass it to ICE to block it, and the other thing I care about is the SHA, what file it got executed. So over here, if you see this, this static value here, this is according to the AMP documentation. This event ID corresponds to malware. So whenever we are looking for this email address, that if malware has executed on any of our endpoints, then this is the event ID which AMP will put. So I'm looking for that. If I find that event, then what I do is that I write two files. I called macaddress.txt and sha.txt. These are the two files being created. And in those files, I will go write all the MAC addresses and all the SHAs which are found. So if we execute this code, so we will say Python and the file name. So you could see this is the URL. and boom, it got bunch of stuff scrolled through. What actually it did, if I list now, it created two files for me, macaddress.txt and sha.txt, right? So if I go and just do more on MAC address.txt, it looks like this. It has these are the endpoints MAC addresses on which the malware has executed, right? And if I say more on sha.txt, you will see 256 shas. These are the samples. These are the files which AMP is actually is concerned about, right? So the next step would be to quarantine this, right? So that ICE, my infrastructure, I don't think I can ping that infrastructure, unfortunately. So otherwise I would have executed that. 27. Yeah, I cannot ping that infrastructure today, unfortunately. The VPN is not behaving. Let's see if I can, otherwise it would be, yeah. But let's move forward. So the other way is, like, I want to quickly just show you guys what I have done in it. Unfortunately, I could not demo to you guys, but let's look at quickly what we are doing on the ICE side, right? So if I look at my ICE boot off endpoint.py, this file, what it does, same thing. It reads the config file, right? Get all the ICE information. And then what it does, this function creates a payload for ICE, because you could see that two things I need to send to ICE. One is the MAC address. So I go in the MAC address list, get the MAC address, put it here. Then I go and find the policy. I've already created a quarantine policy, and all I do in ICE is apply that quarantine policy to the MAC address. And so what happens is that when that device come up on the switch, it will be, according to the policy, will be moved in a certain segment of network. So that's all I'm doing. I'm reading the file, and you could see that I have found the quarantine policy. So first thing it does, it goes and looks up what is the quarantine policy from ICE. So it does a get, right? You could see it does a get request. The next thing it does is actually go to the MAC address list from the file and just apply the quarantine policy to those MAC address. And if you could just see, it just does a put there, hey, these are the things I want to quarantine. So it's a very simple code. Unfortunately, I cannot execute and show it to you guys because somehow the network is, VPN is not working for me from this location. So, so next step would be, once I've quarantined the host, ICE has done its job. Now I want to do the research, right? So next step would be I go to threat grid, right? So and get observables on that. So this is my threat grid code. Again, I'm reading the config file right over here and building up getting all my keys and everything, right? And then I'm gonna go and actually quarantine. Go and get the sample behavior, right? So over here I'm getting the sample behavior, and whatever behavior I get, I put it on two lists I created, domain list and IP list, and basically I write those domain and IP in the list, right? So let's see how this get executed, right? So Python, so when I execute this, it will pick up, so it's picking up SHA from the list. You see it's getting observables. It found so many IPs it has contacted, and it's picking up these files from the list. If it doesn't find any samples, it will let us know that it didn't find those samples. Like samples made outbound connection to following IPs. It's writing that, fixing next one. You could see it gives us, you could see Bing and GitHub and whatnot, right? So these are built all kind of, so what it did, it actually created a text file, which is domain ipheader.txt. You guys saw that? So if I do more on domain ipheader.txt, you could see this is the predominated domain. These are the IPs. You could say it's looking up Bing, it's looking up GitHub, it wants to evade, it's looking up Dropbox, it's doing all kind of stuff, it wants to evade, it wants to mimic like a normal browser, or it is trying, that particular malware is trying to mimic like a browser, because browser can go anywhere. It can go to Bing, it can go to Google, it can go to Dropbox, it does all kind of stuff, so that it evades the sandbox thinking, oh, this is a Chrome browser probably. And so it's doing all these lookups. So it has built that file for me. So the next step is I want to know from Umbrella where this disposition on these domains, right? And if they are malicious, then I want Umbrella to enforce on them. So if I look at the Umbrella code, so I go in the code. So first thing I want to see, it's the same repetition, read the configuration file, build the URLs. The first function I have is domain disposition, right? So you go to Umbrella, you give the URL to Umbrella, and it gives you a status back, and you look for status. If it does domain status is -1, then domain is bad, it means it's malicious. If it is 1, then it's clean, like Google will be clean. And if domain status is 0, then Umbrella is saying, I'm not sure, it's kind of risky, right? So domain risk is based on your policy, you may want to block all the risky domains, right? And what I'm doing over here is that I'm reading all the domains from the file. I'm filtering all the, we saw a lot of duplications. So this is a simple function which is just getting rid of duplicates. And after the duplicates are getting released, then all I'm doing is getting the disposition. And if I found anything which is bad or risky, I'm just saying enforce, just block them, right? So this is where I'm blocking them. This is all the code is doing, right? So let's see what happens over here.
Hey, sorry for interrupting. We have just a little bit over time. I just wonder whether you can show the students how they can maybe follow up with the code that you are presenting, so that they can maybe run some of these activities also on their own computers.
This code is already on GitHub. I put the URL in the slide deck.
Okay, thanks.
Yeah. So I just wanted to quickly show you guys, like on Umbrella, what we just did got enforced. So if I go to Umbrella login and show you guys. Unfortunately, I am in a location, CISCO office. Somehow the network is a little tiny bit slow, so please bear with me. So this is how the dashboard of Umbrella looks like, and in the policies we have what we call integration, and inside integration I created like wheel test. This is where you would see I blocked all my domains. So if I say C domains, you see over here, these were the domains which we were blocking, which we found bad, right? So another tool based on all these APIs which we have built, this is a product which we have built totally on APIs, using APIs. Like this is a beautiful dashboard, and you can do remediation on it. This is called threat response if it works. If I can log in, looks like I have a problem with logging in with that. Okay. So any more questions in the meantime?
Hey, Christian. Yes, we do have some questions. So, Christian, do you mind going over just a little bit to answer some of the questions, and then we can wrap up?
Okay.
Since we did offer them the Q&A, I wanted to be able to answer some. And huge thank you to Joseph and Wadi. I know that they were both answering questions. So, Christian, I think that the best way for me to do this is I'm going to take the ball back real quick and share my desktop. I have a Word doc going. So we'll do it this way. I will bring this up. So guys, if you don't see your question on here, it was on here, and then I was deleting questions as they were being answered by Joseph and Wadi. So again, if you don't see your question on here, please go and check the chat window in the Q&A panel, because it has been answered there. So the first question was, does Security Plus cert carry any value towards Cisco's security path?
I don't understand the full context of this security path. It is like certification path. Maybe Joseph and other folks may be better to answer this.
Okay, Joseph, do you mind going? It's one of the very first questions after all of the hellos. So the next question.
I will answer it on the chat. No, I will answer it on the chat.
So the next question is AI used to prevent attacks?
Absolutely, and there's a lot of AI behind the scenes in the products like Umbrella or Threat Grid. There's a lot of those algorithms have been used. Yes, there are companies now which are out there which are exclusively projecting themselves as AI-based prevention endpoint solutions. So there is a company called Salance. It starts with CYLANCE. There are a lot of startups out there which are doing work in that area, and most of our Cisco products in the background are using a lot of AI.
Awesome, and thank you. The next question is, how are you competing against Relay in the aspect of cybersecurity?
We are not. There is no. I mean, we have a whole integrated security architecture solution. Most of our products they work very well together. They feed each other the intelligence, and I think there is no single product which can actually defend you. So when your products start working together along with the other products, which with customers deploy in their network, is way to gain an upper hand against adversaries. So I think Cisco products, they are all open based on most of the open standards. They have APIs in them. You can integrate a nice a solution using Cisco products. So if you have Huawei products, Cisco products, IBM products, or Salance products, you can all have APIs, so you can create customized solution for yourself. So I think that's the way to win, in my opinion, in the security realm.
Thank you, Christian. And guys, I know we are a little bit over, but we did want to answer some questions. So if you didn't have a question and you need to go, please feel free to jump. But the next question was, how can an individual secure their homes from a cyber attack, keeping in mind that they are not in the field of IT?
Yeah, it's a very simple change you can do. If you go to Google and you Google OpenDNS, OpenDNS is our product, which is Umbrella. OpenDNS name server addresses. You will get those name server addresses. There are 2 of them. All you need to do is put those name server addresses in your server. That instead of using your ISP DNS server, they should use OpenDNS DNS server. And every request, then if it is already malicious, then Umbrella will provide you the same thing for free, and you can block those. Right? So you don't have to do anything. You have to just put those 2 name servers there, and you will get that advantage. So go on Google and look for OpenDNS name servers, and you will be getting 2 IPs. Just put those IPs as your name servers in your home router, and your home will get the protection from OpenDNS.
Thank you. And then the next question is a little long, but you can see it on here.
Google offers something similar too. So go ahead.
So the next question, what if someone is interested to become a security specialist? Is there any course or list of courses, certifications that the organization can recognize him as a security specialist? What are the requirements to become a security specialist?
Yes, there are a lot of certifications which are available. Some of the certifications require you to have some experience, like CISP is CISSP. Is a certification which is very well regarded. CISCO, CCNA, I think Joseph can probably answer those much better, certification questions, which are available. And I don't know, Joseph, there is a learning path in Network Academy for those certifications, I would guess?
So in the Network Academy, we have certification paths towards the CCNA security and the CCNA cyber ops course at this moment.
Yeah. So that's a good place to start.
And then, Joseph, correct me if I'm wrong, I haven't seen a certification on firepower for Netacad, but is there any certifications covering firepower?
Oh, absolutely. So in the CCNA security course, we also cover firepower, only briefly, but it's being covered also over there.
Perfect. Thank you, Joseph. And then, Christian, what do you suggest courses, tools, learning materials to help me learn more about firepower?
Yeah, so in my presentation, maybe if you don't have that slide, let me quickly show folks. I wanted to show, but developer.cisco.com/firepower. If you go there, there's a whole video course there which you can actually go access. There are learning labs associated with it. There is a free sandbox available to you where you can book time and play with the API, play with the UI of the Firepower Management Center, Firepower Development Manager. So yes, you have a lot of assets to play if you want to learn Firepower or learn to code against Firepower on developer.cisco.com.
Thanks, Christian. And so what about just two more questions maybe? Or I guess there's three more left. What are the best security tools for protecting company systems from attacks and as a security engineer or penetration testing engineer?
Tools, I think best tools to protect is segmentation, like I told. There are a bunch of pen testing tools which are available, which you can go buy. There are some free available. There are some available, like they are paid. They are pretty awesome. OSAP, if you're looking at specifically on web-based attacks, OSAP publishes a lot of content on it. There is a Z attack proxy which is available, so you can find vulnerabilities on web-based applications. It's called the Z, like the last alphabet, ZED attack proxy. It's free. I think it is part of Kali toolchain. So if you have Kali Linux with you, Kali Linux comes with amazing tool set for penetration testing for free if you're trying to learn. So if I would start there, I'll install a Kali Linux and go from there. It has all the tool chain in it which you require to do first go or first stab on penetration testing. But tools to protect network is find the vulnerabilities and segment. And more you segment, the better you protect.
So there was a question, how will you classify zero-day threat investigation automation using Python, intermediate or advanced?
Can you please repeat that, Kara?
Yes, absolutely. How will you classify zero-day threat investigation automation using Python, intermediate or advanced? And I can share my screen again, and if you'd like to, I'm sorry, I quit sharing.
Yeah, so I think I would consider that towards advanced. Most of the organizations who have very sophisticated security operations teams would like to automate a lot of their repetitive workflow. If you look at from this perspective that there's a lot of false alarms raised by threat intelligence systems. So you have to repetitively go and log into multiple UIs, look at this information. From the security analyst point of view or security engineer point of view, that's pretty daunting because you are doing context switch from UI to UI, and it is error prone too. After all, we are human, and when we do context switch, we tend to do errors. So if the workflow is very repetitive, like you have to do certain things anyway, so if you automate those workflow, chances are that you will reduce a lot of that context switch. You will be more efficient, and your workflow will not have errors. And hence, those organizations seriously think about automating their workflow. And that's where the Python and APIs play a crucial role.
Thank you so much, Christian. I appreciate you staying on to answer some questions. Guys, we are 15 minutes over, so I am going to go ahead and close this out. But again, a huge thank you to Christian for delivering such a wonderful presentation. The feedback that's been coming through the chat window to me has been wonderful. So thank you for volunteering your time to help our Netacad students.
Thank you so much everywhere, guys. My Twitter handle is Veer@Cisco. If you guys have any questions after the session, you can reach out to me on Twitter.
Awesome. And another huge thank you to Joseph. Again, I know a lot of you, again, familiar names on the call. Y'all know Joseph just through the Q&A panel throughout this series. So thank you, Joseph, for answering so many questions in there for our students and instructors as well. Just a quick reminder, if y'all are interested in starting in cybersecurity, we do have a self-enroll course set up that is free. It is 15 hours long, and again, it's self-paced. It is beginner level, but I will go ahead and share the link in the chat window if you'd like to go ahead and sign up for that. We would love to have you come join us there. And then again, it's a very quick turnaround between today and the next programmability with Cisco DevNet session, but it is May 8th, so next week. And that session is Play with Linux and Python on networking devices. So if you enjoyed today's session and you've enjoyed the other sessions, please join us next week. And we hope to talk to you soon, everyone. So thank you again to everyone.
Yeah, and on June 19th, the bot session also is pretty good. You guys can automate using bot, the workflow as well. So pretty awesome series.
Awesome. Christian, are you delivering that session?
No, it's not me, but I'm just saying that whatever we did today, you can actually write a bot to do that as well. So it's a good session to attend, and maybe you guys can do a project on it.
Oh, awesome. Good. Okay. Yeah. So join us for both. The series is wrapping up. So it'll be your last 2 chances to join another live session.
Thank you.
Thanks, everybody. And the security link is going in the window.
Thank you.